right, our next speaker is going to be talking about research on the design of Mars analog habitat, the case of Habitat Narte in Brazil. Please help me welcome Julio Rezende.
I love it.
Thank you. We have something to pass or need to...
No, yeah, you just need to use the arrows on the keyboard.
Okay. So it's a great pleasure to be here, and thank you so much for your attention. We will be talking about the process of some improvements that we are doing in Brazilian Mars analog research station. Okay, the name of the Brazilian research station is Habitat Mars. In this case, we are talking about some improvements that we did during 2019. We have some partners of the Mars analog research station. Here we are based in the corner of South America. Sometimes when we are talking about Brazil, the people have an image about the rainforest, but we have different ecosystems. Here we have the area of the rainforest, but we also have other ecosystems. And then in this area, in this yellow area, it's called semi-arid. We don't have a lot of rain in this area. And then here we have our maps to locate our location in Brazil and South America. Then there's an average about the current day in this area, like 92 Fahrenheit. Some average during the day we have between 67 to 87 Fahrenheit. And then we have some common problems in this area related to water scarcity and sometimes water reservoirs collapse. Also a decade of drought and some difficulties in agriculture economy. Okay? And then this motivates the operation of Habitat Mars. And in our case, about the operation of research station, we try to do a link between space and semi-arid. We try to do this integration. In this case, how research on space, sustainability, and semi-arid would be integrated is our important question. Something interesting that I'd like to discuss is about something that we have in common to space habitats and also in habitats in arid and semi-arid regions is trying to build a circular space. In this case, in these areas, we need to develop their own food production, sometimes the reuse of the sewage, also the using renewables, and also the waste recycling, because in the United States, these kind of areas is also called off-grid environments. So, areas, some housings that are not integrated in the energy grid. Something important for us is about the connection with the Sustainable Development Goals. In this case, what we're doing there is trying to popularize the STEM, science, technology, engineering, and math. And this we are inviting students to visit this area, students from public schools in areas, poor areas sometimes. And then we are to bring some technologies to combat the poverty and the hunger. And also, when we are talking about space, we are talking about quality education too, because sometimes they can see a perspective to be a student in a university, and do the next steps in a higher education. And this is very important to us. And then also inviting girls to be part of our initiatives. And this is important for the future of the kids, because they would be they will have good opportunities in terms of distance work, and also in terms of the innovation, see opportunities in terms of innovation and entrepreneurship, okay? And also reducing inequalities. Then, in our model, we are trying to advertise what we're doing. I was part of a mission in MDRS, and MDRS produces all the reports of the missions is publicized on the website of my society. And then we share also all our reports, but until this time in Portuguese, the reports. And then we are also looking for some opportunities in terms of partnerships with everyone that would like to be our partner. And the research development that Narte is connected with sustainable communities and also responsible production and climate change and recycling and quality of life and sanitation. When you see the next slide, some activities, some research that we're doing that is connected with these subjects. And then you have some images from public schools in the visits in this area. Oh, sorry. And then we're also doing presentations in schools to kids, and also in conferences, like a conference in the city of Natal. And now we are showing more specifically about the facilities of the Habitat Marte. Is in the semi-arid region. You can see the main building and also the old photo of the greenhouse, and then some pictures from inside infrastructure. And then the beginning was we started with this area, 60 square meters, and then after we built airlock, and then was built the biohabitat. And then during this year, we did we invest in the expansion of the area, and we created a renovable area that is storage. The next lab is a machine shop, and then recently we created the library, and also we are creating an area to recycle the organic waste. Okay, and then this was originally was a gold pen, it's a coral, and then this was renovated to operate the receive the operation of Mazanog Research Station at that mine. Then we'll show you some missions during this year. In our case, we don't have funding yet, and then in our case, the missions operates during the weekends, but we'd like to have a larger missions, like in MDRS of 1 week or 2 weeks in the next months, when we have some funding to operate this possibility. Then we'll show you how the infrastructure, the design was improved during this year. The March, we did the connection of energy and water with the biohabitat. In this photo, you can see a biohabitat, so the greenhouse in the first step, not just the walls. And then in the end of March, we are constructing the greenhouse and working with aquaponic system. It's aquaponic systems. We have a fish tank. The water circulates to these grow beds where we plant some food. And then we are developing what we call in the space aqua, smart aquaponic for space added circular system. We are developing some automation processes using Arduino, and this is the system is also used to control the temperature, humidity, pluviometric levels, refrigeration activation. And here's in June of this year, this is a basil. We also, some issues we are improving creating new routines about our operation. And also here in the end of June, we are consuming the first plants produced in the biohabitat. In this case, this mission we consume lettuce produced in the biohabitat, in the greenhouse. And then some improvements were done during also here we are, in this photo you can see the monitoring of the quality of water. Some parameters are controlled. And then in August we produced for the first time the pesto sauce. The pesto sauce produced with in this case, basil planted in the greenhouse was the first meal prepared with the pesto sauce of the Habitat Narte. And this was a library that we prepared in August. And then, now in the end of the month of October, we prepared the organic waste treatment station, a specific area to treat the fish. And we consumed for the first time fish meal. The fish is tilapia, and then is the fillet of the tilapia fish, and this is the plate, And then the main achievements in terms of design was the operation of the biohabitat. In this case, we would like to expand this greenhouse because till now the food produced here is not enough to the consumption of each mission. And in this case, our goal is the emissions only consume the food product only produced in the biohabitat, the greenhouse. This one, in terms of expansion and renovation, we created a machine shop, with some tools inside. And this was the library. This library, I give the name of my father because today, October 18th, he will be alive. He will be celebrating 100 years today. Yes, I'm happy about this. And then we give the name of the library to my father. And in this case, we are interested in partnerships, sometimes participation in Habitat Narte missions or guidelines, donations, or supporting mail letters. In our presentations, we are showing some logos, some brands of some companies that are possible supporters. And then in this case, we have, I was writing about 10 advantages about compare with others medicinal administration stations. In this case, we are growing food permanently, fish or vegetables, a possibility of scheduling missions according to demands of our candidate, high commitment in the publication of articles, student orientations regarding scientific initiation, possibility of developing long-term experiments, several months, possibilities of these experiments we follow remotely, low thermal amplitude, like 20 degrees, association with sustainable development goals, connections with community, receptions of visits from schools and universities, emphasis on circular economy and recycling precepts as part of the materials are highly reusable. We are using a lot of recycled materials to prepare the facilities too, and attention priority in applying outcomes address threats of climate change. And then we also being invited to UNOSA. I don't know if everybody knows UNOSA, United Nations of Outer Space Affairs, in next November will be, today we have a student, part of the crew, presenting what we're doing in Washington, D.C., a parallel event to International Astronautical Congress. And this student, David, today is in a conference in Washington, D.C. And November will be in a conference of NOSA in Vienna, too. And then we are making this link between space and sustainability, also doing this dialogue. And then, we have some limitations about what we're doing, but also related to funding too. And then this is one last image. Then I did this in PowerPoint. Two important issues that we'll be doing for the next missions or next years is long-term missions. Long-term missions with more following some guidelines also Shannon Robert presented today, and also adopt a more something space-like habitat design. Those are some of the two important goals to our next steps in next months. Okay, then these are some of my considerations about what we are doing in Brazil. If you have some questions about or some suggestions, we are open. And thanks so much for your attention. Tatiana first.
I have my hand up right away. I have to know who takes care of the crops if you're only there 2 days a month.
Yes, we have a person that is still he likes administrator that he lives in the area
Okay.
and all the days he's putting the food to the fish, and the other process is like automation, because the water circulates by engines, and the main goal is only to put the food to the fish, but we are trying to develop a mechanism to develop this like automatically. Practice.
Yeah, all right, very, very specifically, because of the protein return on the feed, why did you choose tilapia?
Yes, we are connected with some researchers in the University of Natal, and then they present to us, and we consider to adopt this possibility, because the tilapia, something interesting, the physics of the tilapia becomes less the water like nutritive to the plants. That water is carried to the plants, no? And we did some experiments giving less food to the fish, and then some plants becomes to die because there's less nutrition in the water. And that is interesting. Then we put more food to the fish, and then the plants becomes to grow more vibrant. And then we are considering also develop other research related how to produce the food to the fish too. No? Great. Shannon, more questions?
Well, I'm just impressed because at MPRS we gave up on aquaponics. It's my firm belief that when we go to Mars we'll plant crops in soil like we always have, because it's amazingly complex and hard to maintain.
Yeah.
And so I'm really impressed that you have such a huge aquaponics construct and that you're successfully operating. In my experience, the amount of effort you have to put into aquaponics compared to what you get out is just not worth the effort. It seems like you've had a totally different experience.
Yes, we need to, each missions, we are controlling the levels of ammonia and nitrites, and also to see if the water is a good quality to the fish. And sometimes we, in some missions, we take the fish to see the membranes, how is the health of the fish, if it's in good conditions or not, because sometimes it have some degenerations in the body, and sometimes this would indicate some not good quality of water to good environment to them. And then we need to have something very interesting that we are doing here that I'm not talking in this presentation. We developed a lot of routines, and protocols. And since I believe these protocols, and we have other presentations tomorrow about specific about the space food production. And then this presentation tomorrow, we'll talk about more about space food production. And then we are talking about more about the routines. Then I believe the one main achievements that we had was these routines, how they care about to manage this process.
So I understand that you eat the fish.
Yeah. For
What do
the
you
next
do?
time.
Will there be fish on Mars? Could one bring fish to Mars? And secondly, does one eat the plants that the feces of the fish help to grow? What do you do with the plants?
I was reading in some technical papers, talking about one of the difficulties about grow food in the space. In this case, they are experiencing in the International Space Station is because the plant's not growing correctly because it doesn't have gravity, and then they need new varieties of some plants to we have a good development of the plant. And then other questions, I don't know, I don't have the answer, but it's interesting to know how the fish will be living in an area without gravity. I don't know the answer, but it's a very good question to look in the internet. There's some NASA experiment. I don't know if they just test the fish in the International Space Station.
But could the plants be edible? The plants could be edible. You could eat the plants.
Yeah, yes. In this case, in International Space Station, they also developed experiments with plants, and some plants was consumed in the International Space Station, but according to what I read, 8% of the plant cultivated in the International Space Station come back to Earth to some laboratory examinations.
Well, on the fish issue, the fish are already neutrally buoyant.
Yes.
Yeah.
How would a change in gravity affect that?
Yes, good answer, yes. Yes.
Yeah, because they're already.
Yes, good. The only thing is, in this case of space, you need a contained water tank, because sometimes the water will be
Going everywhere.
And then in this case, it will be like a environment contained with water inside and the fish and oxygen to the yes.
It seems like it might not necessarily affect the fish, but it could affect the quality of the water because you don't have an even distribution of aeration in the water that you would otherwise have.
Get stratification, for instance.
And then I thank so much for the attention. And tomorrow we'll be talking more about the routines and protocols. I believe the main achievement of what we're doing in Brazil is about these protocols, because I really believe that will be shared to other space habitats. Okay, thanks so much for the attention.